Currently at Oak Ridge National Laboratory, we're trying to understand how do we integrate quantum computers with our existing computing ecosystem. That's a fundamentally difficult problem, both because of the technology differences between these different cultures, but also because of the differences in how we might use those two types of systems. Someday, we are going to need a quantum HPC engineer, a person who understands those two worlds and can address the convergence of these ideas around a single hybrid concept. One of the things that we've started doing is creating summer schools. These are unique opportunities for students all the way from high school into postgraduate education to have opportunities to learn about the exciting research that's going on within the centers. When the students finish the schools, they're then ready to begin their careers in research and development of quantum science and technology. Of course, we hope they come back and join the DOE National Quantum Information Science Research Centers, but there are many opportunities available for students today to become engaged in this exciting field. The past several decades have seen remarkable advances in the development of quantum science and technology, and we anticipate that the future holds similar exciting opportunities. Some of these, of course, are related to the technologies that we're developing to increase scalability and mitigate the noise that is actually limiting current quantum systems today. Quantum error correction and its development into fault-tolerant operation is a key technical area where we see lots of exciting interest and developments that are happening right now. Breakthroughs in those areas are likely to lead us to scalable quantum computing systems that can actually tackle some of our major computational challenges. That'll open up a new frontier of computation that we've not yet seen and be an exciting development both for the field of quantum science and technology, but also for the world at large. It actually has a strong connection to many other topics that are under development for computation. One of these is artificial intelligence. We can anticipate that quantum computing will become an accelerator for understanding artificial intelligence and its applications. So on the horizon is this emergence of quantum technology, both as a scalable system, but also the broad range of impacts that it has, not just on computation, but on many application areas. Also on the horizon are some important investments in instruments and facilities that will be essential for the activities going on in quantum science and technology. We recently opened house on the Translational Research Building. This is a unique facility that was developed specifically to house things like quantum information science experiments. It meets all the necessary engineering and thermodynamic conditions required in order to get the most sensitive measurements of these unique technologies. In addition, we are anticipating that the Spallation Neutron Source will house a second target station that not only provides us greater detail about how materials behave, but couple that insights with our development of quantum computing platforms to simulate those same materials. The integration of these unique facilities and the development of quantum science and technology creates a new frontier for scientific discovery that moves us well beyond where we are today. In addition to our developments in quantum computing, we're also seeing exciting developments in high-performance computing. These systems are not only becoming larger as they scale up in terms of their power and size, but their applications to artificial intelligence, machine learning, and other areas is identifying key opportunities for quantum technology to make a difference in the types of computational problems that are important to society. As we create new systems like the Discovery system expected at the Oak Ridge Leadership Computing Facility, we'll have opportunities to integrate quantum computing with high-performance computing and explore an entire new frontier of how computation operates at both the classical and the quantum mechanical level.